So in this video, we're going to learn about medians and midsegments. There's going to be 5 parts of triangles that we're going to learn, and we're going to do 2 of them today. So here's your objectives, which is mainly just knowing what our midsegments and medians are. And then you can apply theorems about midsegments and medians, and you can state what a centroid is of a triangle. Alright. So a midsegment. The midsegment is a segment that connects the midpoints of 2 sides of the triangle. So to draw a midsegment, you have the midpoints here, and then you connect the 2. And that, what I just drew, is a midsegment. Now, down below, I say how many midsegments does a triangle have? Well, if you connect all the midpoints together, we have a total of 3. Alright, so each of these lines here, and notice inside they form a triangle formed the opposite way. Alright, so then there's something called the midsegment theorem. With this theorem, I'm going to show you a sketch pad of what it is. So up here I have a triangle, and these dots right here are our midpoints. So I'm going to make a midsegment. And I'm going to measure that length. So AB is 5.62 centimeters. And then I'm going to measure the length of the bottom part of the triangle. And you will notice the relationship between them. So as I make my triangle, let's get it to something where you can really. AB is 5 centimeters, and CD is, it's supposed to be half. It's just, we're just a little off on, I'm guessing one of my segments aren't quite. Right. So as I move my triangle, so you can see it stays half. Alright. Moving around. There you go. You see that the midsegment is half the length of DC. And I could draw your other midsegments here, and that'd be true. Now notice that these two are parallel to each other. The midsegment and the side are parallel, that is half. Alright, so going back here. So the midsegment is half the length of the side that it is parallel to. So in other words, if this is 10, this length here is 5. And notice that they are parallel to each other. Alright, so using that I can apply, using that theorem I can find the value of x on this problem. This length here is 16. Here's my midsegment. We just learned that the midsegment is half. So this length here is 8. Right here. Now notice this right here is a midpoint, which cuts the side in half. So if this length is 4, this is congruent to that, because this is your midpoint. So this is also 4. Alright. So on B, use triangle GHJ, where A, B, and C are the midpoints, which means this is the same. These two lengths are the same. And then the same thing down here. Alright. So then we're going to find the value of x, because then we need to use that to find AB. What is this length here? Well, AB is 3x plus 8. This length here. GJ is that. Well, how does AB relate to GJ? Well, we know this is half, or if I double AB, so I take this times 2, I get my length. So I can set up an algebraic equation to help us solve. So I can do I can do 2 times 3x plus 8 right? Because if I double AB, that gives me the entire length of GJ equals 2x plus 24. All right. So continuing solving that, I can distribute my 2. So I get 6x plus 16 equals 2x plus 24. All right. Then I can move everything to one side. I'm going to do 2 steps at once. I'm going to minus 2x to both sides. I'm going to move my minus 16 to the other side. And I'm left with 4x equals 8. Divide by 4. X equals 2. Alright, so now that I know what x is, I can find the length of AB by plugging in 2 into there. So I go 3 times 2 plus 8, which is 6 plus 8, which is 14. So AB equals 14. Alright. So that is your mid-segment. So now we're going to look at medians, which are very similar in the sense that they both deal with a midpoint. So a median is a segment from the vertex to the midpoint on the opposite side. So your vertexes are your corners of the triangle. Right? So I take from the vertex to the midpoint on the opposite side. So I find the midpoint over here, and then I can draw my median. Alright, so this is a midpoint. So then this gets cut in half. So the question here, how many medians does a triangle have? Well, if I go from every vertex to the opposite side, there are 3 medians. One thing we're going to be dealing with a lot with the parts of the triangle is something called a concurrent line. A concurrent line or segment or rays, or when 3 or more lines, segments, or rays intersect at the same point. So here I have 3 lines, and they are concurrent because they all intersect at the same point. The point of where they intersect at, that point right there, is called the point of concurrency. And there's some special things that are going to happen with the point concurrency, and some theorems are going to involve when we're dealing with the different parts. And we're going to do the first one today with the median. Alright, so let's go back to Sketchpad. I'm going to get back to where I started. So I have the midpoints, so I'm going to make medians. So I go from vertex to the midpoint. Alright. So I have my 3 medians inside the triangle, like so. Alright. Well, notice they are concurrent. They all intersect at the same point. I'm going to make that point just like that. So when I move around the triangle, changing the lengths, they all stay concurrent. Alright, so there's something special that happens between this length and then the length beyond the point of concurrency. So let's label some points here that we haven't got labeled. So let's look at E, F, and FG compared to the entire length. So let's measure EF. Oop, I have too much selected. Alright. So if you notice, this length here is half the length of this length here. And then when I move around the triangle, that stays true. And I can move any point. It's always half. Or in other words, this length is 2/3 the distance of the entire thing. Alright, so let's write this down in our notes. So the medium of the triangle intersects at the point that is 2/3 the distance from the vertex to the midpoint of the opposite side. So it's really wordy, so let me show you what I mean by that. So on this line is the point of concurrency, where all the three medians intersect. Whoop. My pen got happy there. Sorry. Alright, so here's a point of concurrency. The distance, we have a distance here, the entire length of this. Alright, if I wanted to get this distance, this right here is 2/3 the distance from the vertex to the point, and this is 1/3 of the total distance. Or, in other words, this is twice the length of this. So if I knew this entire distance was 9, I take 2/3 of 9, which makes this part 6, and then 1/3 of it would be here, which would be 3. The point of where all those lines intersect is called a centroid. There's going to be many different names here, so a medium name for the point of concurrency is called a centroid, and we'll be practicing that, your vocab in class. Alright, so let's just do one quick example. So G is a centroid of triangle ABC, where AD is 8, AG is 10, and CD, the entire length, is 18. So we need to find the length of the segment. Well, BD. Remember, these are midpoints. So this and this are the same. So if DA is 8, BD is also 8. Alright, then the whole length of AB would be those two added together, which would be 16. Alright, so EG. So we have the length of AG is 10. So remember, this 10 is double the distance of the smaller part. So EG is 5. Alright, that makes the whole length of AE 15. Alright, lastly, we have CG and DG. Well, now we know CD is 18. This length right here is 2/3 of 18. So I take 18 times 2/3. Sorry about the bell. So 2/3 of 18, which comes out to be 12. So CG is 12. And then DG is 1/3 of 18. So 1/3 times 18, which is 6. Alright, to review, the mid-segment, remember, both of these use midpoints. Let me do a different color so you can see it. Okay, the mid-segment goes from midpoint to midpoint on the sides, and it's half the length the side is parallel to. And then the median goes from the vertex to the midpoint. And then your theorem that 2/3, this is 2/3 the length of the entire thing, and then this is 1/3. Or this is double the length of that. Reminder to do a reflection so you get credit for watching this video.